You're listening and watching to Inside iOS Dev, show about real-world iOS development. Today with you, your host, Alex Bush. And I have a special guest again, Sandeep Agarwal. Hey, Sandeep.
Hey Alex.
So in this video, we are going to be talking about a tweet that we saw. And I think, Sandeep, that was you who kind of lurked on Twitter, if you will, and noticed this
Yeah.
from Fred. Who posted this question to all of the Swift people out there. And he's asking, how would you refactor something like this? And this is a sample code that he came up with. And I think throughout the whole, people had many suggestions, which we'll probably touch upon in this video, what the suggestions are. But he, told, he said that this is a sample code. It's not from an actual project, because a lot of people were asking, oh, why a customer object, which sounds like a model object, right, has all of this services and stuff. But what Sandeep and I figured we should do, we should kind of go over this example and try to refactor it with sort of our ideas on what needs improvement here and how you could tackle it to make it easier to work with and easier to change down the road, right? Because that's sort of with any code base, what's important is how easy it is to change, right?
And how easy it is to maintain.
Right, and how easy it is to maintain. So yeah, and this is what we're gonna do in this video, and it's spoilers. It's gonna be a lot about dependency injection, but not only though. And we'll see where we get with this, because we're sort of doing it not live necessarily, but we have not kind of prepared anything ahead of time except just talking it through among ourselves. So we'll be coding with you guys as you're watching this video and kind of doing more or less real life scenario of how we pair program, right? Where we have a legacy piece of code that in this case happens to look like this, right? Even though it's an example, and how we would go about changing it and refactoring it and so on. So we've got this terminal application prepped, Swift Mac app, which is basically just has a main function, nothing in it as of right now. And it has this, what you guys saw in this tweet, right? It has this customer class, and we declared all of its dependencies, as was noted here. Something was a struct, something was a class, something was a protocol. We have them all declared here in this file. And yeah, so that's our starting point. Sandeep, from the get-go, what are your initial thoughts on this?
So it seems like customer object is trying to do so many things at a time. Uh, so what the actually tweet asked, that tweet guy asked, that how can I refactor this object like with so many initializers? So to make the customer object, we have to pass like so many services inside it.
Mm-hmm.
Uh, but the thing here is, why do we need it in the first place? Do the customer requires to do all such lot of stuff?
Yeah, right. Yeah, and I think this is what a lot of people kind of pointed out in the replies to this tweet. They were saying things along those lines, right? Why does this thing even has to do all of this in the first place? And Fred said that, well, yeah, this is just an example, right? It's exaggerated, if you will, and yeah, not real life. But this is the if you in real life see something like that, that's maybe not a customer object, but maybe a presenter or a view model that also injects so many things and which means it depends on so many things, right? Because that's the logic here. If you have store of all of those in your properties, that means this object depends on it. And that's the what you said, Sandeep. That's the biggest first question. Why does it need to depend on all of those?
Right. Even if it was not a customer, but entirely different object, why it is doing so much,
Right,
right?
exactly.
It's
Yeah.
violating the single responsibility principle clearly.
Clearly, yes. It's just too many things, right? Um, and it would be, if it was a real life example, right, we would actually know what exactly it needs and what it exactly does by looking at the rest of the code, right? There would be a bunch of functions that do stuff over here, right? And a bunch of variables, maybe computed properties that do other things. And in there, I would assume y- um, this object would refer to those injected services, and that would give us a better idea on actually what are the methods from each one of those services that are called, and therefore this thing depends on, right? But
Mm.
since this is an example and we don't have any context of the rest of the code, we're I think it's safe to assume that yes, you this object does call at least one method or property from each one of those, right? Which
Mm-hmm.
means it needs them. Even though, yes, likely, why the hell all of those single responsibility is broken. But I think the next step, sort of to also illustrate and maybe showcase that, yeah, illustrate and showcase mm, how this has become the telltale signs of this becoming growing in responsibility, right? And having too many things. Well, of course, obviously, what we're looking at is already large and long, but also as you want to instantiate this object and initialize it, right, to somewhere else in your code, you will just working with it, you'll notice that you have to supply all of those things, right? You have to supply all of those objects, and this is becoming unwieldy, right? Just too much stuff
Mm-hmm.
to either give, right? Let imagine this code was inside of some other class or something, and you maybe provide some of them like login service, but then this registration service you have to instantiate. And same with analytics service, you probably need to instantiate that as well. And then I don't know, cart service, same thing. You get it from maybe that, object that you're in, right? Um,
Yeah, I mean, it's fine to, if it was just at one place, I think I would have stayed with that. But if this object is initiated and used at multiple places, and so I think it demands a factory.
Yes, yes. And okay, before we get to that though, I
Mhm.
agree. But before we get to that, I think we should kind of start with a bit simpler um, helpers that are still kind of violating a lot of principles, but could at least somewhat improve this, at least on the usage case, right? That we
Mhm.
can start with. And specifically, I'm thinking as the simplest iteration to this. If assuming, so assumption here, let's assume that you actually, um, every time you initialize this thing, right, you actually are creating uh, uh, all of these objects from scratch, right? There are new instances. So you're not really mm, getting them from anywhere else, right? All right. So here, right, let's assume that this is how this is called. Oh, sorry. When the customer object instantiated throughout your application in multiple places, every time you do something like this, every time you initialize a new instance of each one of those services to be injected into this object. And by the way, notice that some of these are not book service, they're actually book service implementation or financial service implementation and so on. This is because they are protocols, as was per the example code, right? But we have to supply the actual instance, right? We cannot instantiate a protocol, so we just have this dummy
Mhm.
conformed
Yeah,
dummy
makes
class.
sense.
Mhm. So so yeah, imagine you have this. How you can help kind of the simplest, easiest approach, help at least initializing that stuff, right? Uh, you could have default um, what is it called actually, Sandeep? Default value in
Uh,
param.
yeah, yeah, default value.
Yeah. So for example, right, you definitely can implement this, or sort of put this inside so that every time you call it, you don't have to mm, initialize login service yourself, that object, right? Same with registration. They're not protocols, they're just structs, right? So it's sort of easier to do. And let me do the rest. Uh, All right. So here, what we did, um, we moved this again, assuming that this is done every time when the customer is initialized, removed an instantiation of all of those dependencies into the customer's initializer object as default params, right? Like this. So that allows us to do this, essentially having the customer init call without any params, right? So that's at
Wow, we
least
have a small initializer now, right?
right. And we potentially, if we want to, let's say, supply only one of them, right, we can actually say as a different implementation, um, different object that implements the same thing, right? If it's behind a protocol, then we can do something like this, and the rest of them gonna be set by default, right?
Nice. So
So
does it solve all the problems?
right. So this doesn't solve the problem, honestly, at all, right? The only improvement that you get with this
Mm-hmm.
is easier instantiation. So for the users of this class, it now becomes a bit easier, right? And technically, there is still full control because you can still technically, supply all of them if you want with your own instances if needed, right? Um, but it actually, the side effect of that, it grew this initializer implementation even more, right? And yeah, so not really, doesn't really solve the original problem, but at least some marginal improvement um, for instantiation. Okay, so another approach you could take with this, and I think that would, hmm, it would certainly help with the reducing the initializer size, but it will not fully solve the problem, and you still, uh, yeah, you still have to kind of tackle that. Um, so what you could do is this: you could declare these properties are public as of right now, right? In this example, so they're accessible from the outside of the class. So you could say customer analytics service, for example. But since they're lets, they are getters only, right? And they can only be read, not written to. So what we can do, we can make them variables. And we can move this default setting of them from the initializer to the property declaration itself. So what this allows us to do, if we have all of these properties set at the instantiation through the property default values at the instantiation, it actually allows us to do this and completely get rid of this initializer, which technically sort of helps with the original question of the um, author of this tweet, right? How do you refactor the large initializer and help with its size, right? And you still have the ability to supply different implementation for those objects, and specifically for those behind an interface, right? Uh, Later on, right? So this will not work because, or both of those, because you don't have the initializer with params anymore. But you could then, after initializing this object, you could actually supply one of the services and say basketball service, new service, right? So this technique is called the
Property
original.
dependency injection.
Yes, this is one called property dependency injection. The original was the initializer dependency injection. There are pros and cons to both, and specifically, in the professional applications and the code bases out there, what you would see the most and where it's the most robust approach is this one, through initializer, injecting dependencies through initializer, because this it sort of makes your class, you don't have to declare vars anymore. Those dependencies will be lets, which means it's more immutable, right? Which means at runtime execution of this customer object, when it's passed around your code base, no one can alter the internals of it by setting some other dependency, right, and switching it under you. So it sort of makes it more. What was one of those objective-oriented principles, like, or solid principles, open closed print or something like that, uh, where
Of what?
essentially it's you kind of configure your object, and it cannot be modified after that. It's initialized, and it's a immutable unit, if you will. Where with the approach of property instantiation, as I was mentioning before, or property dependency injection, your object is vulnerable to unexpected behavior, right? And changes to what it depends on at
I'm
runtime.
not sure about that actually, Alex. If there is any such principle,
Well,
I mean,
I
you can
think
cut
it's,
off this thing.
yeah,
You can
yeah.
cut off this conversation.
I think it's not the solid principle. It's the objective oriented thing, one of the best practices or whatever it's called, but I don't remember exactly how it was phrased.
Mm-hmm.
Um, but anyway,
I mean, I can raise one more point actually.
yes.
And Alex, I think it is also because when we do it this way, it will actually initialize these dependencies two times. Like whenever you initialize the object and when you actually supply that dependency. In your case, when you're supplying analytics service, it was already initializing it in the init phase and then again initializing it when you supplied it from outside, right?
Yes, that's actually true, right? So in the scenario of well, actually both scenarios, right? The property injection or the initialization injection, but having the default values. Yeah, you'll have sort of two objects, right? So in this case, when customers initialized, let's say you only have this, right? This basketball service will be initialized immediately. So there's one object is created, and then you create another one to supply it, right? So this technique is only for the scenarios where you're not happy with the default, or you don't need the default object here, right? You want some other object, so you would like to replace it. um Unfortunately, I mean, in Objective C, that I believe, if I recall correctly, it was doable, but in Swift, is not because Swift is a more strict language. Technically, what you could have done, well, sort of, you could have done this. You could have got rid of all the default implementations, assignments here for each property. So what you could have done, you could have got rid of all the default values. But now, since the compiler says you have to supply it either via default property at initialization or in the initializer itself, right, as the default value. So as an alternative, you declare them all weak properties and optional, so there could be nil, and then later you supply them, right, like this through properties, and that way, technically, you solve the whole large initializer problem because you don't have it anymore. But the alternative is that all of your properties are weak now and optional, right? And you are not holding on to them, which is not good. You probably don't want that because if if you're dependent on an object, you probably want to retain it.
Right, and mm, it is also not good. Like if we are requiring that service in the customer object, we can't just make it optional, because although we are requiring it, it's a requirement of that interface to have that service. We just can't make it optional so that we can just initialize it easily,
Exactly,
right?
that's a great point. Yeah, because if they're all optional, that means some users of this object might forget or not supply on purpose one of those objects, thinking that it will um, work without them, right?
And you may get weird behaviors at runtime because
Exactly,
of that.
exactly.
The compiler won't even catch it because you have already asked the compiler, hey, we are making it optional, it's fine if user doesn't supply that,
Hmm.
right?
Yeah. And the whole idea behind this dependency injection and declaring it like that, and specifically through initializer, this gives essentially a public API, a clear, transparent public API to anyone who wants to use this object, that in order to for this object, in order to operate and function properly, it needs all of these objects and relies on them. It needs them to be supplied at instantiation, right? And that's that's why it's actually good, even though it's large, right? This initializer, but it's good that it's an initializer like that, and that those properties are lets, right? So they're immutable.
All right, guys. So this was the refactoring technique for reducing the complexity or like improving usability of a large initializer. In the next episode, we will tackle different ways of approaching this and kind of expanding on what we've just done. But if you like this episode, please like and subscribe. Subscribe to the channel, like the episode, maybe even click that bell icon in YouTube to get notification when the next episode is out. It helps a lot, and this way, to beat the algorithm, and this way you guys you get notified when the next video is out. With that said, thank you for watching. See you next time.